This is going to be a slightly different video because I will be making notes here, and this is also going to be a slightly system design video where we are going to actually discuss a real world system that is used by many big companies in their day-to-day operations. Well, this system is none other than the Dynamo DB. Dynamo DB is a NoSQL database offered by Amazon, and it is pretty fast. That is, it provides like sub-second latency, so whatever requests you make, you get the reply back in milliseconds, and it can be also modified to be read heavy as well as write. Well, let's discuss some of the points about Dynamo DB in detail. Well, in case of Dynamo, or in case of any distributed database like Cassandra, etc., you have the concept of partition key and the sort key. Well, the partition key and sort key serve different purposes. Together, they compose the primary key. The partition key's use case is that your data is not on a single server but distributed across shards or different servers. Let's say that you have server 1, server 2 and server 3. Well, they can also be called as partitions. So you can see here in the photo that we have like 9 partitions, partition 1 to partition 9, and let's say that a request comes in. The request is about a customer ID and or order ID. It goes into the request router. The request router determines the partition for this data object in O1 complexity. So it simply hashes the customer ID and it creates a partition key, and that is always deterministic and fixed. So if you have seen my previous video, which is Foursome, there we tried implementing our own hashing techniques. So in a similar manner, the request router hashes the customer ID and creates a partition key that decides that which partition this request will go to. So this data object is saved to that partition, and it is not only saved to that single partition, but it is also replicated across different partitions, because DynamoDB uses the concept of consistent hashing. Well, what is consistent hashing? That is technique that we will learn in one of the next videos. But for now, you can assume that the data goes to a single partition always. That is, given customer ID will always go to the same partition again, and it will be also read from the same partition. But it is also replicated across different partitions to make it more fault tolerant, as we will see ahead in this video. So the request router takes in the data, it creates a partition key and routes the object to that partition. The partition can be spread across different availability zones. So P1 can be in AZ1 or availability zone 1, P2 can be in AZ2, and so on. Now, how do these partitions communicate with each other? Well, they use a protocol known as gossip protocol. That is, there is no concept of leader and follower here. As in case of many distributed systems, there is one single leader that takes in the request and then it is replicated across the followers, and the read request can be made to the followers also. And in case when the leader goes down, one of the follower becomes the leader and the request is routed to that leader. But in the gossip protocol, the partitions talk with each other. That is, each partition is a standalone entity in itself and there is no such concept of leader here. So every node is a node in itself, like they are the leader in themselves. They are unique, they are independent, they have their own identity, and they just gossip with each other to know that what is going on, what kind of data do you have, are you available. So they also send their heartbeats to other nodes, so they know that the nodes are online, and they just add it to their table, which is, I think under the hood they use DHT, but I'm not sure, I will have to look it up. But basically they just keep a track of all the nodes and that they are part of the network. So they know that this is the network I'm part of and these are the nodes that are my peers and they are all equal. So any request can go to any node. For example, if some data is stored in partition 1 P1, but if the request goes to node P2, P2 knows instantly that sites in P1 and there is such partition called P1, and it fetches the data from that partition and gives it back to the user. So one of the good features of DynamoDB is that it supports heavy writes and heavy reads. You can configure your DynamoDB to be such that it can give you features for heavy writes and heavy reads. Well, in case of heavy reads, you can assume, or you can even think that in case of heavy reads, there are many read operations that are going to the database, so our data is not strongly consistent, but it is eventually consistent. That is, if you want to query something, it might not be available in that node, but eventually that node will have that information or that data will be available there to be read. Now let's discuss a bit about quorum here. So quorum is directly related to consistency. So if you want your reads to be consistent, in that case you need to define a high quorum. That is, when a request goes to a partition, the data is written to that partition, but it also needs to write it to some other partitions and get an acknowledgement from those partitions that the data is written. So let's say that the data goes to P1 and quorum is 2, so you need 2 more nodes to write that data. Let's say that the data is written to P2 and P3. P2 and P3 acknowledge back that, hey, I have written back this data on my disk, on my SSD. Then P1 is sure that since the data is written back to P2 and P3, it can return it back to the user. And this is definitely more consistent than having a low quorum where data is not written to P2 and P3 and it is just written to P1, and at a later point of time it is synced to P2 and P3, so they have the data written to their disk eventually. So that is eventually consistent, and having a high quorum makes Dynamo DB strongly consistent. And you can define this in the settings yourself. If your application requires heavy number of read operations, then you can have a lower consistency here. Now, one of the features that is supported in Dynamo DB is concurrent writes. So you can write the data to any nodes at any point of time. Let's say that multiple nodes are handling the write request simultaneously, and if the same data is being written to 2 different nodes, node 1 and node 2, it can be quite problematic because the same data is being written to 2 different nodes. So what is the consistent state? We need to be sure here. So for that, Dynamo DB supports MVCC. I am not sure about the full form here, but I will just look it up quickly. So MVCC is multi-version concurrency control. It means that, let's say that there is some item that we are writing to partition 1 as well as to partition 2, then it will be written to partition 1 with version 1 and it will be written to partition 2 with version 2. So it knows that since both of these partitions are writing with different versions, it will overwrite the data and maintain a single version, which is the latest version, which is V2 in this case. Now, the other thing that DynamoDB supports is consistent hashing. As we discussed earlier, each item has a partition value. So it goes to a particular partition, and there we can also have an order key defined, which maintains the order within that partition. So the data is sorted within that partition in a particular order, which is defined by the ordering key, but more on it later. So let's say that we have data which goes to partition 1 and we have some other data that goes to partition 2. The value of these hashes which partition the data goes to will be same throughout. So if we want to fetch that data, we would be fetching it from partition 1 if the hash value resolves to partition 1, else from partition 2. Now, consistent hashing here means that the data value having hash from 1 to 10 will go to partition 1, from 11 to 20 will go to partition 2, and from 21 to 30 will go to partition 3. This is just a simple example. So basically the data is divided across different partitions and there is not too much load on a single partition. If there is a load on a single partition, we can call it hot partition, which is like very active, but mostly the data is replicated across different partitions, and DynamoDB handles these things internally, so we don't have to worry about a partition being a hot partition or something. So as I discussed before, partition key defines the shard. In case of many distributed databases or distributed systems, the data is replicated or distributed across different shards, and sort key defines the order in which the data is sorted within the shard. Now let's think of an example here. Let's say that we have a restaurant that we are maintaining and we have a software and we are getting many orders on our application, and the order is in one of 3 states. The order is either pending, it is either ready for pickup, or it can be completed. And we have like different restaurants. We have a software which manages orders across different restaurants. It can be a food delivery application, for example. So what we can do here is that based on the restaurant, we can define the partition key. So we know that the data of a single restaurant goes to one single partition. Now, since that data is clubbed together, it is easier to fetch the data for that restaurant in one go. Now we can think about how we will be defining the partition key as well as the ordering key here. Well, the partition key is obviously the restaurant ID here. here, but the ordering key can be the order status, or we can have a single status as the partitioning key. Let's think about the difference here. If the partitioning key is the order status, then the order status can be one of all three statuses. So if we want to fetch the different orders of a particular status, let's say I just want to know the orders that are ready for pickup, I'm making a query every 5 seconds to know which orders are ready for pickup so that our delivery guy can get that information and go to the restaurant or something. So obviously I cannot make order status as the ordering key, because every time I am making query to the Dynamo DB partition, it will fetch all the orders for that status. So for a single status, it will actually scan across all the sort keys or all the keys in that partition and then filter out the orders that are ready for pickup. But we don't want that here. So what we can do is we can actually define the ordering key as ready for pickup. So within that partition, we are storing the order by ready for pickup. So all the orders that are ready for pickup will be on the top of the shelf. So if you want to pick those orders, those will be picked up pretty quickly. So this is actually a challenge. You need to choose your partition key and ordering key in such a way that it fits your use case. So for a delivery app that is focused on making multiple queries to Dynamo DB at regular intervals for a particular order status, then I would want that order status as the ordering key and not the actual order status, but particular order status. And this is how you can make your Dynamo query faster and cheaper. So thanks for tuning in. I will just paste all the links, the important links through which I studied about Dynamo DB in the description. And I hope you enjoyed the video. We will do a slightly deeper dive in one of the systems again in the next video. And if you like the video, then consider subscribing to the channel, and I hope to see you in the next one.